All right, this week we're going to be looking at animal behavior. Before I get into that, I just want to update you all on what the next few weeks are going to look like. So this week we're doing animal behavior, and your circulation results and discussion and references are due this week. So make sure you have that before you come to lab. This is our last animal lab. And so after this, we're going to go into an animal practical review where your TA and peer TA will be there to answer any questions that you may have. And then the next week, we'll go into our animal practical. The week before spring break, we're going to have time dedicated for you to work on your blog. And during this week, we're going to ask that your blog post plan is due. And all that is just a sheet where you indicate who your partner is, and then what organism, structure / function you want to look at. But we have a sheet for you, and we'll give that to you in the coming weeks. And then you'll have spring break, and then we'll go into the plant section. A little bit about the blog post. So what we're going to ask you to do in 3 weeks is to choose a partner and an organism that you want to write a blog post on. So it can be any organism that focuses on the life history or focuses on its life history and a specific structure and function that that organism has. So examples are the sundew with its modified leaves with sticky tentacles, with the function of capturing prey for nitrogen acquisition. Or we have an animal example would be like an octopus. And so the structure would be its suction cups for gripping surfaces, prey or rock, or gripping surfaces, prey or rocks. So yeah, it can be, I will say that we've had people in the past do fungus, so you're not limited to just animals and plants. So a little bit about what you're going to be doing in lab today is there are 2 parts. You're going to be looking at the trail tracking behavior of termites, and then we're gonna look at in part 2 we're going to be looking at cricket behavior, specifically their levels of aggression when presented with different not stressors but different conditions, we'll say. So there's not much to the first part, but we're going to be you'll familiarize yourself with the different castes of termites. And so we'll have a couple different castes for you to look at in lab. Definitely we will not have all of these castes, or we've never seen them all. But there will be enough for you to see the different types. And then we're going to be going into looking at the termite senses. So you're going to be comparing, in the first part, you'll compare compare a pen and a pencil to the termite's trail tracking response. And then you'll do a quick experiment afterwards, basically like trying to understand why you think you're seeing the behavior that you're seeing. And so this could be a number of things, and your TA will go over different ideas with you in lab, but they can be a preference in the color of pen or pencil. They can be the type of pen or pencil. They could be how sharp or gradual the turns are, or the gap in the trails. So basically you're just gonna trying to figure out why the termites are doing this trail tracking behavior. For part 2, we're going to be looking at cricket behavior. So a little background information. Crickets are known to compete for food, for access to a mate, and for shelter. And so different conditions will affect the outcome of this competition. And by competition, I mean like fight, basically. And so, for example, like whether crickets know each other or not, if two crickets know each other, they're likely not going to fight each other because there's already like a dominance hierarchy set up. Who was in the territory first? So normally whoever was in the territory first is dominant and will display dominant behaviors. Whether the newcomer is the same or of opposite sex, and so it depends on whether or not the cricket will show aggression based on like whether or not it's a male or a female. So if it's a male cricket in the environment and you introduce a female, it'll likely not try to fight it because it will try to mate with it. And then whether or not the crickets are hungry is also just another condition that could affect who wins or not. And so we're going to be observing and recording behavior in crickets to evaluate how some of the above conditions might affect how they behave. And so here I just want to show you the difference between the females and the males. So the females have this ovipositor on the rear of, or the back of their abdomen. So it's just a long, skinny black tube for laying eggs. And then the male just does not have this. So that's the main difference between the two. And then this is from this diagram is from your packet. And so it's just showing some different levels of aggression or different ways that they can be showing aggression. And so I will say I won't say anything. We're going to be observing cricket behavior. It's going to be great. So there's quite a few different behaviors that you could be seeing, and we'll have all of these written on a board so you can remind yourself of what they are. I won't go through all of them, but there's quite a few like neutral behaviors that the animal can be doing, like antennae cleaning, drinking. However, we don't really put water in there unless you want to. Trying to look for other neutral things. Leg cleaning, eating, singing and chirping. So those are all kind of neutral behaviors. Some positive interactions are obviously like mating and ovipositor insertion. And then there are obviously our negative behaviors, which could be anything like wing flaring, which I believe is on, they kind of are wing flaring in this mandible engagement picture. Following or chasing, guarding, pushing, so they'll push each other with their heads, biting, obviously. And so these are just some of the different categories or behavioral categories that you're going to be looking for. And so there's two parts to this experiment. First, you're going to be observing the behavior of a male and a female from the same population. And so this is meant to be kind of like a control. So we expect that if you put a male and a female from the same population, not much is going to happen. Just because they know each other and there's probably already a dominance hierarchy set up. Also, excuse me, also the male is not likely to fight the female or the opposite way around because they can mate. So once you guys do that, you'll look at part 2, which is you're going to be looking at adding 2 different males from a different population in to see how the control male reacts or what different behaviors they might display. And so same goes for the female. They can display aggressive behaviors as well. So that's about it.